Alright, welcome everyone. In this video, we're going to briefly just talk about line notation and this kind of abbreviated form of writing electrochemical redox reactions. Okay. So how does line notation work? Okay, you first write out something like this, okay, where in here you have something that's being separated by two vertical lines here. Okay, this is indicating the salt bridge, right? To the left of that is your anode, which has your oxidation reaction. And to the right of that is the cathode that has the reduction reaction. Okay? And again, the two vertical lines is the salt bridge, okay? And then these single horizontal lines are separating kind of the solution and the electrode, right? Which is the electrode, again, could it be involved in the electrochemical reaction or not? Okay, it doesn't have to be, right? And often that's indicating different phases, right? Your electrode's often solid, right? Your solution has aqueous species, okay? And so this is what's called the line notation for redox reactions, okay? So I can write out an overall redox reaction in this very simple form, and you can know what's happening where, what's being oxidized, what's being reduced, how these are separated from each other, what are the electrodes, and things of that nature. Okay. So for example, right, I have this redox reaction using this line notation, right? In this case, the two electrodes are just inert platinum catalyst electrodes, okay, right? And then again, I have my anode here, which has my oxidation reactions, and my cathode here, which has my reduction reaction. Okay. Right. And none of the things involved in the redox reactions, right, are able to transport electrons from one side to the other, right? They aren't solid metals, so we need to include things, something like platinum, which is an inert metal that can just conduct the electrons from one side to the other. Okay. Right? So that's kind of that line notation. And so when we're talking about electrochemical reactions, okay, if we want to know which direction the reactions are going to go, we want the direction that has a positive cell potential. Okay, that type of electrochemical reaction is called a galvanic cell. So a galvanic cell has an E cell that is positive. Okay, so E cell is greater than 0 for a galvanic cell, and it is a spontaneous electrochemical reaction. Okay, so a spontaneous electrochemical reaction has a cell potential greater than 0. Right? And so if I want to describe a galvanic cell, I need to, right, and I'm given kind of that like line notation and things like that, right? I need to talk about what is a cell potential, right? What is the balanced electrochemical reaction, right? The redox reaction. Where are the electrons flowing from, right? What's at the anode? What's at the cathode? Okay. What are my electrodes? And what type of ions are involved in my different compartments and such. Okay.